हेलो एवरीवन। आज हम द थ्योरी ऑफ फर्म अंडर परफेक्ट कंपटीशन चैप्टर पढ़ेंगे माइक्रोइकोनॉमिक्स का। इन द प्रीवियस चैप्टर वी हैव स्टडी द कॉन्सेप्ट रिलेटेड टू फर्म, प्रोडक्शन फंक्शन एंड कॉस्ट कर्व. The focus of this chapter is different. Here we ask, how does a firm decide how much to produce? The answer to this question is by no means simple and unreasonable. Assumption about the firm behavior. A firm we maintain is a ruthless profit maximizer. So the amount that a firm produce and sell in the market is that which maximizes profit. Here we also assume that firms sell whatever it produce, so that the output and the quantity sold are often used interchangeably. The structure of this chapter is as follows. We first set up and examine in details the profit maximizing problem of a firm. Then we derive a supply curve. The supply curve show the level of output that a firm chooses to produce at different level of at different market price. Finally, we study how to aggregate the supply curve of the individual firm and obtain the market supply curve. Perfect competition defining features. In order to analyze a firm profit maximizing problem, we must first specify the market environment in which the firm function. In this chapter, we study a market environment called perfect competition. A perfect competition market has the following feature. The market consists of a large number of buyer and seller. Each firm produces and sells a homogeneous product, that is, the product of one firm cannot be differentiated from the product of any other firm. Entry into the market as well as the exit from the market are free for firm. Information is perfect. The existence of a large number of buyer and seller means that each individual buyer and seller is very small compared to the size of the market. This means that no individual buyer or seller can influence the market by their size. Homogeneous product further means that the product of each firm is identical, so a firm can choose to buy from any firm in the market and she get the same product. Free entry and exit mean that it is easy for firm to enter the market as well as to leave it. This condition is essential for the large number of firms to exist. If entry was difficult or restricted, then the number of the firm in the market could be small. Perfect competition implies that all buyer and all seller are completely informed about the price, quality, and other relevant details about the product as well as the market. This feature results in the single most distinguished characteristic of a perfect competition: price taking behavior. From the viewpoint of a firm, what does the price taking entail? A price taking firm believes that if it set a price above the market price, it will enable to sell any quantity of the good that it produces. On the other hand, should the price less than or equal to the market price, the firm can sell as many unit of the good as it want to sell. From the viewpoint of a buyer, what does the price taking entail? A buyer would obviously like to buy the good at the lowest possible price. However, a price taking buyer believes that if she asks for a price below the market price, no firm will be willing to sell. No firm will be willing to sell to her. On the other hand, should the price asked be greater than or equal to the market price, the buyer can obtain as many input of the good as he desire. Price taking is often thought to be reasonable assumption when the market has many firm and buyer have perfect information about the price prevailing, charges the same price. Suppose that a certain firm raises the price above the market price. Observe that since all the firm produce the same good and all buyers are aware of the market price, the firm in question loses all buyer. Furthermore, or as the buyer switch their purchase to other firm, no adjustment problem arise. Their demand is really accommodated when there are so many other firm in the market. Recall that now. Recall now that an individual firm inability to sell any amount of the good at a price exceeding the market price is precisely what the price taking assumption stipulate. Revenue. We have indicated in a perfectly competitive market a firm believe that it can sell as many as unit of the good as it is want by setting a price less than or equal to the market price. But if this is the case, surely there is no reason to set a price lower than the market price. In other words, should the firm desire to sell some amount of the good, the firm that it should set exactly equal to the market price. A firm earn a revenue by selling the good that it produces in the market. Let the market price of a unit of a good be P. Let Q the quantity of the good produced, and therefore the sold by the firm at a price P. The total revenue of the firm is defined as the market price of the good, P multiplied by the firm output. Hence, TR equal to P into Q. To make matter concrete, consider the following numerical example. Let the market for the candle be perfectly comprehended. Let the market price of a box of a candle be rupees 10 for a for a for a candle manufactured in table 4.1. Show how the total revenue is related to the output. Notice that when no box is sold, total revenue is equal to 0. If one box of candle is sold, the total revenue is equal to 1 into rupees 10 equal to 1 into rupees 10 equal to rupees 10. If two box of candle are produced, total revenue is equal to 2 into rupees 10 equal to rupees 20 and so on. We can depict how the total revenue changes as the quantity sold changes through a total revenue curve. A total revenue curve plot the quantity sold or output on X and the revenue earned on the Y axis. Figure 4.1 show the total revenue curve of a firm. Three observations are relevant here. First, when the output is 0, the total revenue firm is also 0. When the total revenue curve passes through the point origin O. Second, the total revenue increases as the output goes up. Moreover, the equation total revenue equal P into Q is that of a straight line because P is constant. This means that the total revenue is an upward rising straight line. Third, consider the slope of the straight line. When the output is one unit horizontal distance, OQ1 in figure 4.1, the total revenue vertical height AQ1 in figure 4.1 is P into 1 equal to P. Therefore, the slope of the straight line is AQ1. Slope of the straight line is AQ1. The average revenue of a firm is defined as the total revenue per unit of output. Recall that if a firm output is Q, the market price is P, then TR equal to P into Q. Hence, average revenue equal to TR by Q equal to P into Q. P into Q by Q equal to P. In other words, for a price taking firm, the average revenue equal to the market price. Now consider the figure 4.2. just देख लेते हैं, ठीक है. 4.2. Here we plot the average revenue or the market price y axis for the different value of firm output. firm output XSS. Since the market price is fixed at P, we obtain a horizontal straight line that cut the y-axis at a height equal to P. This horizontal line is called price line. It is also called the firm average revenue under perfect competition. The price line also depicts the demand curve facing a firm. Observe the demand curve is perfectly elastic. This means that a firm can sell as many units of the good as he wanted to sell at price P. The marginal revenue of a firm is defined as the increase in total revenue for a unit increase in the total firm output. Consider table 4.1 again. The total revenue from the sale of 2 boxes of candle is 20 rupees. Total revenue from the sale of the box 3 of candle is 3 rupees. Marginal revenue equal to change in total revenue by change in output. 30 minus 20 by 3 is minus 2 equal to 10. Is it coincident that this is the same as the price? Actually, it is not. Consider the situation when the firm output changes from Q1 to Q given the market price price P. MR equal to PQ2 minus PQ1 divided by Q2 minus Q1. P को बाहर निकालिए Q2 minus Q1 divided by Q2 by Q1 equal to P. Thus, for perfectly competitive firm, MR equal to average revenue equal to P. In other words, for a price taking firm, the marginal revenue equal to the price market price. Setting the algebra aside, the institution for this result is quite simple. When a firm increases its output by 1 unit, this extra unit is sold at a market price. Hence the firm increase its total revenue from the 1 unit output expansion. That is, marginal revenue is precisely the market price. Profit maximization. A firm produces and sells a certain amount of good. The firm profit denoted by pi 1 is defined as the difference between the total revenue and the total cost of production. In other words, total revenue equal to total revenue minus total cost. Clearly, the gap between total revenue and total cost is the firm earning net of cost. A firm wishes to maximize its profit. The firm would like to identify the quantity Q1 at which its profit are maximum. By definition, then at any quantity other than the Q0, the firm profit are less than at Q0. The critical question is, how do we identify Q0? For profit to be maximum, 3 conditions must be Q0. The first, the price P must equal to MC, marginal cost. Marginal cost must be non-decreasing at Q0. For the firm to continue to produce in the short run, the price must be greater than the average variable cost. Price must be greater than average variable cost. And the long price must be greater than the average cost. Condition 1. The profit are the difference between the total revenue and total cost. But the total revenue and total cost increases, the output increases. Note that as long as the change in total revenue is greater than the change in total cost, profit will continue to increase. Recall that the change in total revenue per unit change in output is the output is the marginal revenue. Change in the total cost per unit change in the output is the marginal revenue, marginal cost. Therefore, we can conclude that as long as the marginal revenue is greater than marginal cost, profit are increasing. By the same logic, as long as the marginal revenue is less than marginal cost, profit will fall. It follows from the fact that profit to be maximum, marginal revenue should equal to marginal cost. In other words, profit are maximum at the level of output which we have firm profit maximizing output become the level of output at which P equal to MC. Condition 2. Consider the second condition that must hold when the profit maximizing output level is positive. Why is it the case? The marginal cost curve cannot slope downward at the profit maximizing output level. To answer this question, one refers again to figure 4.3. Note that at the output level Q1 and Q2, output level Q1 and Q2, the market price is equal to the market cost. However, at the output level Q1, the marginal cost is a downward sloping. We can claim that Q1 cannot be a profit maximizing level. Why? Observe that for all output level slightly to the left of Q1, the market price is lower than the marginal cost. But the agreement outlined in the section 4.3.1 immediately implies that the firm profit is at an output level slightly smaller than Q1 exceed the corresponding to the output level Q1. This is the case. Q1 cannot be a profit maximizing output level. Firm profit at the output level firm output is slightly lower than exceed the corresponding to output Q1. This being the case, Q1 cannot be profit maximizing output. Consider condition 3. Consider third condition that must hold when the profit maximizing output level is positive. Notice that the third condition has two parts. One part applies in the short run and other part applies in the long run. Price must be greater than or equal to AVC in the short run. We will notice that the statement of case 1 is true by agreement that a profit maximizing firm in the short run will not produce at the output level where the market price is lower than the AVC. Let us turn to figure 4.4. Observe that at the output level Q1, the market price P is lower than the AVC. We claim that Q1 cannot be profit maximizing output level. Why? Note that the firm total revenue at Q is at follow. Total revenue equal price into quantity. Vertical height OP into width OQ1. The height of the rectangle OPAQ1. Similarly, the firm total variable cost at Q1 is as follow. TVC, average variable cost into quantity. Vertical height OE into width OQ1. The area of rectangle OEBQ1. Now recall that the firm profit is at Q1 is TR minus TVC plus TFC. That is the area of the rectangle OPAQ1 minus the area of the rectangle OEBQ1 minus TFC. What happened if the firm produced zero output? Since the output is zero, total revenue minus TVC are zero as well. Hence, the firm profit at zero output level is equal to minus TFC. But the area of the rectangle OPAQ1 strictly less than the area of the rectangle OEBQ1. In the firm profit at Q1 is area AP minus TFC, which is strictly less than what is obtained by not produce at all. So the firm will choose not to produce at all and exit from the firm. Price must be greater than or equal to AC in the long run. We must show that the statement of the case 2 is true by arguing that a profit maximum in the long run will not produce at the output level wherein the market price is lower than AC, average cost. Let us turn to figure 4.5. Observe that at output level Q1, the market price P1 is lower than the long run average cost. We claim that the Q1 cannot be a profit maximizing output level. Why? Notice the firm total revenue. Total revenue at Q1 is the area of the rectangle OPAQ1, the product of the price and the quantity, while the firm total cost is the area of the rectangle OEBQ1, the product of the average cost and quantity. Since the area of the rectangle OEBQ1 is larger than the area of the rectangle OPAQ1, the firm incurred losses at the output level Q1. But in but in the long run setup, if firm that shut down the production has a profit zero. Again, the firm chose to exit in this case. The profit maximizing problem graphical representation. Using the material in section 3.1, 3.2 and 3.8, let us graphically represent a firm profit maximization problem in the short run. Consider figure 4.6. Notice that the market price is P. Equating the market price with the short run marginal cost, we obtain the output level Q0. At Q0, observe the SMC slope upward. P exceed ABC. Since the three conditions discussed in section 3.1, 3.2 are satisfied at Q0, we obtain that the profit maximizing output level of the firm is Q0. What happened to Q0? The total revenue of the firm at Q0 is the area of the rectangle OPAQ0, the product of the price and the quantity, while the total cost at Q0 is the area of the rectangle OEBQ0, the profit of the short run average cost curve and quantity. So at Q0, the firm earn a profit equal to the area of the rectangle APAB. Supply curve of a firm. A supply curve, A is the quantity that is choose to sell at a given price, given the technology and given the price of the factor of production. A table describing the quantity sold by a firm at various price, technology and the price of factor remaining unchanged. It is called supply schedule. We may also represent the information as a graph called a supply curve. The supply curve of a firm show the level of the output plotted on the x-axis and that the firm chose to produce corresponding to different value of the market price plotted on the y-axis. Again, keeping the technology and the price of the factor of production unchanged, we distinguish between the short run supply curve and the long run supply curve. Short run supply curve of a firm. Let us turn to figure 4.7 and derive a firm short run supply curve. We shall split this derivation into two parts. We first determine the firm profit maximizing output level when the market price is greater than or equal to the minimum ABC. This done, we determine the firm profit maximizing output level when the market price is less than the minimum ABC. Price is greater than or equal to the minimum ABC. Suppose the market price is P1, which exceeds the minimum ABC. We start out by equating P1 with the SMC on the rising part of the SMC curve. This leads to output level Q1. Note that the ABC at Q1 does not exceed the market price P1. Thus all the three conditions highlighted in section 3 are satisfied at Q1. Hence, when the market price is P1, the firm output level in the short run is equal to Q1. Price is less than the minimum ABC. Suppose the market price is P2. So the market price is P2, which is less than the minimum ABC. We argue that condition 3 in section 3 that if a profit maximizing firm produces a positive output in the short run, then the market price P2 must be greater than or equal to the ABC at the output level. But notice from figure 4.7 that all positive output level ABC strictly exceed P2. And it cannot be the case the firm supply a positive output. So if the market price P2, the firm produce zero output. Combining 1 and 2, case 2, 1 and 2, we reach to the important conclusion. A firm short-term supply curve is the rising part of the SMC curve from and above the minimum average variable cost together with the zero output at all price strictly less than the minimum ABC. In figure 4 on the bold line represent the short run supply curve of a firm.